All right, so the last two problems here for our introduction, or reintroduction, I should say, back to functions, is just proving certain things algebraically. So let's first have an understanding that we already know the slope, and I'm going to go ahead and try to prove it. We already know the y-intercept, and I'm going to go ahead and try to prove it. So especially if we're into using Desmos and we're able to understand how that works, just going back, being able to prove our work, making sure that everything that we wrote down was in fact correct. So we're going to do these two things. Now, for the slope, we can pick any 2 points whatsoever, and we know that it's the y values subtracted, or the change in y over the change in x. Just because I can see it currently on my screen, I'm actually going to focus on the first 2 points that I have there. My y values were the 16 and the 10, and their corresponding x values. The 16 had an x value of 4 movies, and the 10 had a corresponding x value of 2. And this is a simple one. If I do the math work here, 16 minus 10 is 6, 4 minus 2 is 2. So my slope would be 6 over 2. We know that 6 divided by 2 is 3, and that's enough to check the fact that we knew that the slope was a positive 3 for this particular situation with the movies and the cost. Proving the y-intercept, well, again, this is kind of going to go back to understanding what we have here. And in this situation, we know the linear equation was y is equal to 3x plus 4. And this should be simple enough. We know that if I'm looking specifically at that phrasing, y-intercept, we know that that means the x has to be 0. So all I have to do is evaluate, plug this in. I'll take 0 and plug it in anytime I see x. 3 times 0 is 0. And 0 plus 4, of course, would be 4. And that checks out with what we had up here at the top with the y-intercept being 0, 4. It checks out with the y-intercept being on the back end of that equation right there. Again, just being able to prove algebraically the things that it is that we've discussed within an equation, within a function.